Hello, everybody. This is our car alarm project. My name is Brian Lizarraga.
I'm Brian Rogers.
I'm Carson, Cartagena.
Marcelo, Posse.
I'm Telal Ismail.
And this is for Professor Rodriguez EE 186. So we define our project. The main goal is to prevent a carjacking. And a carjacking, we defined it as the action of violently stealing an occupied car. And we are tasked by designing a car alarm with a system that will detect and prevent a successful carjacking. Therefore, the car alarm must respond to the criminal in three scenarios. The first scenario is stealing the owner's car keys and alarm fob. The second scenario is hot wiring and stealing the car. And the third scenario is driving with the car after threatening the owner with a gun to get out of the vehicle. And we made a library, and these are our assumptions. The thief is completing the crime with intent, breaking into a 2020 Jeep Wrangler models without doors and windows. And the car alarm system is independent than anything that already comes with the car. Our car is a Jeep Wrangler 2020. It has no doors and nor windows, and the price is $28,295. Next, all right, and this is Carson.
So our flow chart, we have 5 push buttons, essentially the engine, key detected button, fail safety button, passcode correct button, and passcode incorrect button. If pushed, engine is on, otherwise it is off. And then when you push the key detected, it'll go down to if pushed, then the key is detected. And if we push the fail safety button, it'll go down. If pushed, then the emergency button has been activated. And when you push the passcode correct button, then the alarm will not be activated. And when you push the passcode incorrect button, the alarm will activate. So this is our fail safety button. It's going to be located next to the key insert button if it's detected. Then when this button is pushed, it will activate the car alarm's timer to disable the car's engine after 5 minutes. But for our situation, we toned it down to 15 seconds. After 5 minutes, the car alarm should activate with car horn beeping and blinking lights activating. And therefore, the driver can activate the car alarm system without the robber knowing. And I'm going to be passing it down to Brian Rogers.
Thanks, Carson. And basically for our car alarm project, the C code, we start off declaring the variables here. And basically for our variables, we had the key sensor, the fail safety, the engine, the car horn, the car lights, the timer, and the keypad. And the keypad's if you enter the correct passcode. And when we start our code, it goes to the survey to check for a certain scenario. And within our survey, we basically have that if the key sensor is detected, then it's going to basically go down here and it will go to passcode check. But if the engine is on, it will go down and it will see engine on here. You can see where it's 1, it will go to passcode check. However, if the fail safety button is ever pressed, then it will go automatically to the fail safety feature. As you can see, if fail safety is ever 1 here, it's going to go to fail safety. And these right here are just to check that it's within the range. And if none of those scenarios have been activated, it's going to go to nothing detected. And here's our alarm. So basically what happens within the alarm for the go-to loop is if the car alarm gets activated, it will tell the user on the print screen and it will set the engine equal to 0 to turn it off. And the car alarm engine will be deactivated and a timer will go off for 10 minutes to repeat the alarm for our C code. And basically what happens is during those 10 minutes, the lights are going to go on and off and the horn's going to go on and off. As you can see, it equals 1 and then it will turn it back to 0, 1, 0, 1, 0. And then what happens is we'll increase our timer and once 10 minutes have passed, we'll go back to the survey to return for the car alarm to check if those scenarios are still happening. And now we're within the passcode check. So within our passcode for this, we created the passcode 13579, and the user's given 3 attempts. And so while the attempts is greater than 0 and the engine has not been turned on yet, it will ask the user to enter the passcode, and it will subtract an attempt each time. And if the passcode is equivalent to what we have stored, then it's going to turn on the engine and the alarm will not be activated. However, if they enter the wrong passcode, it will tell them how many attempts they have left. And by the time they reach over, it will be the wrong passcode. And then this is if the engine is on and the attempts is still greater than 0, it does the same thing, just for 2 different scenarios. And if the attempts equals 0, then it will say that someone's stolen the car and it will activate the alarm. And here within the fail safety button feature, it's going to wait 10 minutes before activating the alarm. So basically what happens is it will see and it will take up some time before the car alarm activates, and then the timer will reset. So if the scenario ever happens again, it will start at 0, the timer, and go up to 10 minutes again. And then this is also our nothing detected go-to loop. So if nothing's detected, it will say the car is safe, and it will go back to the beginning of the survey just to make sure all the scenarios are not occurring. But if one does occur, it can go to that certain situation. And here's just our system pause. And for the Arduino setup of the final project, basic overview, we had an Arduino shield right here. The Arduino Uno's right under the shield. And this push button here is if the correct passcode's entered, it will correspond to the green LED. If the wrong push button's pressed, it will correspond to the red LED. Here's the flashing alarm lights, the blue LED. And we had resistors also in here due to the pull down resistors we used within this project. Here's the car horn, the engine. If it's pressed, it will be on. Here's the failsafe button. So if pressed, it will turn on the failsafe scenario. And here's the key detected. If pressed, it would be 1. And here's our USB cable in where we got our power source of 5 volts. And at this time, I'd like to pass it back over to Marcelo.
All right, thank you, Brian. So here we have a more cleaner looking schematic of the Arduino sensor shield and the Arduino Uno that we have. We have wires going from the various buttons that we just showed you. We have the speaker, we have LEDs, and we have more buttons. Beginning with the Arduino code here, we have a bunch of global variables here. All these pin numbers are assigned to these variables, as you can see. Some are called 12, 11, 6, except for this specific variable here, light counter. It's a counter variable for the car alarm lights. Next up, we have the void setup. This setup code will run once and initializes all the pin modes. Moving right along, we have 4 different functions that happen depending on which scenario has been detected or if no scenario has been detected at all and everything is safe. Just like the Visual Studio's code, if a scenario calls for it, the user has a chance to input their password 3 times. There's a button for a correct one and a button for an incorrect password. If the user enters the correct password, it's going to go to the function nothing detected. If the user enters in the incorrect passcode, the program is going to tell them how many attempts they have left and let them use the attempts as they will. If the user runs out of attempts, then the alarm will be activated. Here we have the function for the alarm. The serial monitor is going to tell the user that the alarm has been activated and the engine has been turned off. Furthermore, the horn will go off for 10 seconds at a frequency of 3000 hertz. As the alarm is going off, the blue LED lights will also be going off as well. Once the alarm is finished, it's going to return to the loop to see if any condition has changed. The fail safety function we have up here will wait for 15 seconds until actually activating the alarm. If everything is okay, then the nothing detected function will be called and the system will continuously recheck if anything changes. And next I'm going to pass it off to Telal.
Thank you, Marcelo. I will go through the cost analysis for our project. First, we have Arduino kit. It included the LEDs, 5 push buttons, 1 speaker, Arduino Uno, and 1 breadboard, and a USB cable, and 220 ohm resistor, some male and female gimbal wires, all of them around 23. And we use Arduino sensor shield, and we use freezing. It's kind of a sketching program. Our total cost is $50.41. The time analysis for our project, for the delivery, we got 7 days. For the planning, we got 2 days. For coding, we got 2.5 days. The installation is 2 days. Troubleshooting is 1.5 day. Preparation and final details is 2.5. The total time for the project is 17.5 days. Here we have some photos for our project from different angles. It shows the all component we used and how we build it together. We have this is the wires with different colors, and the Arduino Uno with shield, and the other one, the one in the middle, we have it from different angles too. If you can see all the components, and the third picture is also the picture took from different angles to show you different components. At this time, I would like to pass it to Carson.
Thank you, Telal. So our references would just be the FritzSync download that we used for the Arduino setup and our Jeep Wrangler 2020 car. And at this time, we are going to play the video that we recorded.
Hello, my name's Brian Rogers, and I'm representing two Brians today, Brian Rogers and Brian Lizarraga.
I'm Marcelo Posse.
My name's Carson, Cartagena.
I'm Telal Ismail.
And this is for Professor Rodriguez's EE186 class, and we're doing the car alarm project today.
Hello, this is Carson. I'm going to be going over the buttons. So over here on the left, we have the 3 buttons for the 3 scenarios. This one's going to be for the key if it's on, and then this is fail safety, and then this is going to be for the engine when it's on, and then this is going to be our horn for the car alarm when the car alarm goes off, and this is going to be the light that signifies the car alarm going off, and these 2 LED lights will be showing whether or not the passcode is inputted correctly, the red being incorrect, green being correct, and then these 2 buttons would signify whether or not the passcode is right. So this will be the incorrect button, and this will be the correct button.
Go.
Hey, so this is Marcelo. I'm going to go over the first scenario. This is what happens when somebody steals your car keys. So by default, the car is in a safe state. Engine isn't on, key isn't on, no failsafe is on. This is what happens when the car detects that a key is in. It's going to ask you for a passcode. So here's what happens when you put the right passcode in. Little green LED shows up, and you're good to go. You can start the car. Now let me show you what happens when you get 3 bad attempts. You get 3 chances to do this right. Here's what happens when you hit it once. Here's the second time. And here's the third time. The tone's going to go off. The alarm lights are going to go off for about 10 or 15 seconds, and then it's going to reset.
Hello, this is Brian Rogers, and I'm going to talk about scenario number 2, the hot wiring scenario. So for this scenario, basically the engine's going to be on, but the keys are never going to be detected, so it will be off. So I'm going to show you what's going to happen. So we have our engine button right here. When I push down, it's gonna find out that the engine's been activated, but the keys have not. So as you can see, it's gonna ask me for the passcode by default in the alarm system. So I had 3 attempts. So I'm gonna show you, I'm gonna enter in the wrong attempt here. And then you can see I have 2 more attempts left, but because I'm the thief, I don't know what the passcode is. I'm gonna try again. Oh, entered it in wrong again. I have 1 more attempt left before the alarm goes off. So I'm gonna hit it again. And now you can see the alarm's going off because the thief doesn't know the passcode. So the car will turn off the engine and it will never start.
Hello, this is Telal Ismail. I'm going to go through scenario number 3. Your car is on, unlocked. Someone threaten you. You want to hijack your car. You're gonna activate the save fail button. After 15 seconds, it will turn the alarm on. For the constraint of the video, we make it 15 seconds instead of 5 minutes. I will push the button.
And 15 seconds are going to pass by until the alarm activates.
There we go. Now the alarm is activated and
Also, the engine has been turned off.
yeah.
And now it's defaulted back to the original setting.
To support this project, we used a regular Arduino Uno board here, and on top of it, we slapped an Arduino sensor shield. We used a bunch of digital pins instead of using buses for voltage and ground. Speaking of voltage, we use 5 volts for everything that's going on in here.
Any questions?